we're asked to integrate y equals cosine of x over the interval from 0 to 2 pi. And then we're asked to find the total area between the x-axis and the graph of y equal cosine of x. Well, number one, we're just asked to integrate. So let's use the fundamental theorem of calculus part 2. So I need any antiderivative of cosine x. Well, sine x will work. Evaluated from 0 to 2 pi. Well, the sine of 2 pi minus the sine of 0 is easy to evaluate. The sine of 2 pi is 0, and the sine of 0 is also 0, and I get 0. So there in number one, I get 0, and in number two, I'm asked to think about an area. And I think drawing a picture will help me understand what just happened in part one. So I'm going to graph cosine from 0 to 2 pi. And we're very familiar with the graph of cosine. Cosine's a nice little wave function, very symmetrical. And if we think about what we just integrated, we'd get this area and this area, but we'd be subtracting off the area we just shaded below the x-axis. And if I think about the shape of cosine, well, this purple area I shaded would be the same amount of stuff, so when I subtract them, I get 0. So that's why, well, I got 0 when I integrated from 0 to 2 pi, but now I'm asked to find the total amount of area. And when I'm asked that, I'm not allowed to think of this as a negative value. So what do I do? Well, I'm thinking about this like it's one of those displacement versus total distance traveled kind of questions, right? If cosine were my velocity graph, then this area I find by just evaluating the definite integral, that would be displacement. So what I would be saying is I went somewhere and then I went back where I started. Well, that's what cosine does. That's what sine does. Sine would be my position equation, right? It starts at 0, it goes up, comes back down, and it ends at 0. So now I'm asked for that total distance traveled, right, where I need to find all of these shaded areas. And so one option would be to integrate from 0 to pi halves and get a number. Evaluate from pi halves to 3 pi halves to get a number. That number will be negative, but I can imagine taking the absolute value of it, so it would be positive, and then from 3 pi halves to 2 pi, and I could evaluate those three integrals. But since cosine is so symmetric, and I already know that this amount of area cancels out with that amount of area, I'm just going to integrate from pi halves to 3 pi halves and get that number, take the absolute value, and then double it. Well, I already know the antiderivative of cosine is sine, and so I'm just evaluating from pi halves to 3 pi halves. Well, the sine of 3 pi halves is minus 1. Minus the sine of pi halves is 1. I get minus 2. So this red amount shaded here would be, well, 2 square units if I was thinking about area. And so I know that this adds up to the same amount in absolute value, so the total area shaded there between the curve and the x-axis is 4 square units. There are 4 square units shaded between the x-axis and the curve.